So before doing more exercises, and they now will become really interesting, I think, much closer to real life data analysis and not just the first or the last row. I just want to mention different ways of doing the subsetting. So we have seen here, and so now I'm just to try to kind of do as I say. I said, well, I like R markdown, they're really useful. So now I'm going to demonstrate these topics in this R markdown file, where I have subsections here and a little R code chunks to illustrate about this. So we have seen here that if I take one after my comma, I extract my first row as a vector. We have also seen that names of IPRG here, okay, returns the column names. So if my first my first column name is protein, I can actually also type IPRG and then protein, because protein is my first column with this, and that will return the same output. Here I do the subsetting with an index, and here I do the subsetting with my column name. Okay. And this is really powerful because here I have an assumption. I want to extract my protein names. Here I assume that my protein names are the first column. Here it doesn't matter where they are, as long as it's called protein like this, and not proteins or with a capital or lowercase p. Okay? So I have different types of assumptions. It doesn't matter whether protein is the first, second, last. So very often when you write code, write scripts, it's good to write it like this. So you know that even if you have a typo, if you have a typo here and I type proteins, I will get an error because it tells me there is no proteins column. But here, if I have typo type 2, I isn't going to complain. It's just going to take the second column instead of the first one. So bugs happen more often than not. But we want bugs that produce an error. If there is a bug and my software stops, okay, I know about the bug, I need to find out what happened. The worst ones are there is a bug and the software just carries on. And I might not realize that something went wrong. Okay. This could happen here if I mistyped it, but here it's less likely to happen. Subsetting by index, subsetting by name. And this is something that we do so often that there is a shortcut for this. IPRG $protein. IPRG square bracket operator, comma, protein, as a character, this needs to be quoted, or IPRG dollar, not quoted, is exactly the same. This is a shortcut with the dollar. The dollar is a shortcut to say, find the column name, the name that matches this bit, and extract it. Yes? No, columns. All in columns. I could also do subsetting using names here. Okay. And I don't know if you remember, the names in this case were not very informative. So this returns row name called 1, in this case it's the first one, column protein. So it returns this cell, which happens to be cell 11, but it's a factor. So what it returns really is a factor, this element, and it tells me that there are 3027 levels in this first column. And this is because I didn't specify strings x factors equals false. But if my row names were informative, then this is something also that I could use. If my row names were protein names, for example, I could type my protein name here to extract exactly that protein. The dollar only works on column names. And to complete the exercise, there is another function that we need, which is unique. So let's create this vector. And if I only want the unique instances of x, I can type control x, unique x, and it will return that same vector stripped from every element that is repeated. Only the unique elements. So with that in mind, here are the questions for you. Focusing on the IPRG data frame, how many conditions do we have? How many biological replicates are there? How many conditions / technical replicates combinations do we have? Okay, you might need to look at the unique documentation or try it out. And then do the subsetting of IPRG and create a subset, not of a single protein with an index, but a subset that contains only condition 1, the proteins, the protein measurements in condition 1, or proteins that were measured in condition 1 and technical replicate A. Okay? Or all measurements that come from one specific MS1, all condition 1s and 2. So this and this is a little bit redundant. Okay, but these are real cases of data analysis that we would have. Very often, instead of before starting to do the full analysis, we would say, well, I'm going to concentrate, for example, on only condition 1, just to make sure that things look fine. So I would start to do the subsetting. And to answer these, here you'll need unique, but to answer these, you'll need to maybe look at the material of yesterday. How can we identify something that is condition 1? Look at your data frame. What do you have into this condition column? And looking at the material that we had yesterday, how can we create now a vector of logicals that match this condition to the subsetting of IPRG? Okay. So once you finish, or you are happy to proceed, green sticky note. If you have questions, call us, or red sticky note. I will put the answers to these exercises during lunch break, so you will have everything, but we'll go through them together. But I would like to try to finish this exercise but by 11:30 latest, and then we can move on to visualization. Okay. Yes? Yes, so I'm just going to qualify like a temporary created file that contains values. And what is really important is to realize that language dimensions are because I extract one and then I ask one question, same question, and so now I can use this temporary variable that I think it's one line up like this. This is extracted those and have true which corresponds to so this yes, we're going to prove it now. And I will provide the answers so you can read them again. Okay, let's do this together before we move on to um, visualization. Now, I appreciate that this is probably difficult or not easy um, because it takes a little bit of time to get used to how to translate questions in English to questions in R. But to answer these questions, we rely on things that we have seen today, which is we have a data frame. How do we subset a data frame? Rows and columns. And we rely also on what we have seen yesterday as we have a vector, and then we ask what elements of a vector are greater than 5 or equal to condition 1, things like that. But we use subsetting and conditions in a very interesting way. So the first question is, how many conditions are there? Well, the first thing I need to check is, well, how many conditions are there? How are conditions encoded into this data frame? So I see that column number 5 is called condition. So I can extract it by typing condition. And here I see that, okay, I have 4 levels. Let me open this up here. So 4 levels, and they are called condition 1, condition 2, dot, dot, dot. No space, so here there's condition 3, condition 4. So I know from this, from looking at the data, and if it was your data set, you would know it because maybe you created this encoding, condition 1, condition 2. But here we first need to look at it, make sure that this is how the conditions are. Oh, sorry, wrong question. The question is how many unique conditions we have. So because this is a level, because this is a factor, we could ask what the levels are, or look here. But more generally, if I want to know, how many they are, how many uniques they are, the easiest is to use the unique function. Okay. And here are the uniques conditions. I can count them, condition 1, condition 2, condition 3, condition 4. Imagine there were 12 conditions, and I could not just, and maybe they are named condition 1 to 3, to 12, maybe condition A, Z, I don't know, strange encoding. If I really wanted to make sure to know how many they are, I could even say length. 4. These are the unique conditions. There are 4 unique conditions, and these are their names. Yes?
Obviously getting the length of that works, but when I just print out it doesn't say how many levels, it just says levels and then lists them all. Which if there's 4, it's easy to count. If there's
Yes. So if you unique here, it prints them out.
Yes.
And because these are factors, it also tells me here are the levels.
And I'm saying mine says levels, but it doesn't say 4 levels and then list them.
Maybe because you didn't use unique, but you said levels. Oh, it is exactly what I have. So if we look at this line, what are the unique elements of this column? These unique elements are condition 1, condition 2, condition 3, condition 4. But because these are factors, it always tells me what levels do I have. Condition 1, condition 2, dot, 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 condition 4. So in this case, it's a little bit redundant. But if these were not factors, if these were characters, I would not have this line of information. Does that answer your question?
I think it's something trivial.
But you have exactly this output here, don't you?
Except for number 4.
Number 4 in the second line.
So under hard bracket 1, where it says 4 levels, mine
Only
just
has
says
levels.
levels.
So the first number 4.
Control
I
L.
think it's on the line. No, it's not. It's on the line above.
So you do not have this output.
Oh,
Now,
yeah, okay.
now this
That's
next
what
one.
we have.
Okay.
But notice your number 4 is gone.
Oh, I see.
Okay,
Just-
because it was a little bit small, there was not enough space,
Yeah.
and so it dot, dot, dot. It adjusted to the space that I have. Okay, that's just a feature of RStudio. It adjusts, it gives me the first few, and then it realizes I don't have enough space, so I'm just going to print out the last one. But you can, here you still have the 4 unique ones, and you could always, you would say length, because again, instead of relying on me counting them, I can ask R to tell me exactly how many they are.
Sure,
Okay, so we all have the same output, correct?
Yeah.
Good.
So how would you get Mark to tell you
How many levels? Levels, and then length of levels. So in the interest of time, so the first set of questions are kind of the same type of questions instead of condition, replicate 1 and 2. And then the second set of questions are, let's not ask information about one column, but we need to extract information in one column and use that to create a new data frame. And so the question we're going to answer together, and I will provide all the answers to everything later on, is what I want is a new data frame that encodes observations, that contains observations for condition 1 only. So we need 2 steps to do this. But we could write it in one line of code, but nobody writes one long line of code by starting. We have 2 kind of steps in our analysis. The first step is to say, I only want condition 1, and I know that I have 4 levels that are named condition 1, condition 2, condition 3, condition 4. Those that I'm interested in are those that match condition 1 like this, with a capital C and no space. So among all the elements in this column, I'm interested in those that are exactly equal to condition 1. So I'm going to store this as a temporary variable, C1. Okay. So let's look at head C1. Head C1 tells me the first is true, 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 false, false. What does this mean? It means that head IPRG condition 1. It means that the first one is condition 1, the second one is condition 1, the third one too. True, true, true. The fourth one is not. It's false. If I look at here, this vector of conditions, it just says false. I don't know whether it's condition 2, 3, or 4. I only know it's not condition 1, which is what I'm interested in now. So here, C1 is a vector that tells me each element in that column, is it condition 1 or is it not condition 1? N row IPRG. Okay. This is the or dim IPRG. IPRG has 36,321 rows and 7 conditions. What is length C1? What is the value in length C1? And this is what I need to know when writing this code. Not the actual number, but I need to know that the length of this vector exactly matches the number of rows in my data frame, because I extracted the column, and then for each element of that column, I asked a question. So I get an answer for each element. So I get as many answers as I had rows in my data frame. This is the important piece of information. This is the habits that we need to know, that we need to get. If I ask a question for one variable, I will get an answer for each row in that data frame. And so now I can use this temporary variable to do the subsetting. Okay.
Just go back when you're creating this C1.
Yes. Yes. So this is one column. What is the length IPRG dollar condition? The length of this is equal to n row of IPRG. Does that make sense? Well, if the length of this column is this, then the length of my answer when I ask this question will be the same, because for each element I get an answer. And because this is the case, I can safely do my subsetting on the rows, not on the columns. And I know that there won't be any recycling here. There is no funny business that happens behind the scenes, because the length of this corresponds to the n rows of this, by definition, because that's how I built it. Okay. IPRG1. I started with a data frame with 7 columns, 36,000 rows. I end up with a data frame that has the same number of columns. I didn't ask to do any subsetting of the columns, but it has 9,079 rows, because there are 9,079 proteins that have been measured for condition. So this you answer in 2 steps. The first answer is which rows correspond to condition 1, and the second step is you use that to do your subsetting. So let's move on to visualization. I'll provide the answers to the questions. And at the end of the day, we have a 1-hour extra practice. So we can see this again, or maybe you can try yourself for the other questions. If you still have questions, you try for yourself and we can go through them together. So visualization, let's start by, okay. One important thing here is, what do we understand by visualization? By visualization, I don't mean producing figures. That would be plotting. Producing figures is not really what I mean by visualization. Visualization is understanding data by the means of producing visual inputs. Okay. This is a means to understand the data by subsetting it, by asking questions. IPRG $condition. Here's a function that we haven't seen, but is very useful. Table. Okay. Table creates a table. What are all the levels? And then it tells me how many levels there are. So this is a way to understand my data by calculating summary statistics. Another way to understand my data is to visualize it. And so visualization is that. It's not about creating figures, nice figures. Of course we want nice figures, but we want these figures to be useful, to reveal interesting patterns in the data. So before we even get to visualization, we need to know how to do the subsetting, how to subset the data, how to transform the data. Visualization is just an extension of data manipulation, where we eventually create a figure that might look good, it might not look good, it might have nice colors, it might have horrible colors, but it doesn't matter. Of course, for our papers, we will want to have a really nice publication quality figure. But if this publication quality figure doesn't reveal interesting patterns of the data, it's useless, whether it's beautiful to look at or not. Okay, that is visualization. So let's start by quickly learning some very useful and very simple visualization or plotting function. So if I want to visualize the intensity, so here I have intensity, my intensity column. One very important feature of any kind of quantitative value is to look at its distribution. Oh, so I'm just going to change this tools, global options, and here I want to have plots. So I change this so that my figures are here and my console is there. Okay, so histogram produces, hist produces a histogram. Okay? So this tells me that the distribution of all the protein intensities, whether they come from condition 1, condition 2, a biological replicate, particular replicate, whatever protein, have this distribution. So whether this figure is beautiful or not title is a bit funny. The title actually doesn't make any sense unless you know that you had a data frame called IPRG and that we extracted column intensity. Otherwise, it's a very bad title. For us, it makes sense. But this figure tells us something really important, is that this is the distribution of our intensities and might not meet the requirements or the expectations if I want to do some tests on my data. So there is another column in this data set called log2 intensities. So let's produce the histogram here. So these are the same intensities that I had before, but log2 transformed. And here I see that after doing these log transformations, my data has completely different properties. Now, it has this typical bell-shaped data that we like to see because we know that if our data looks like this, we can make assumptions and do additional tests. So this was the hist function. And I will not now spend too much time into the customization of these figures. These details are given in the notes. But just to give you an idea, I could customize the title by providing a main argument. Okay, so by say main equals hello, I update the title. So producing nice figures can be time consuming if we start to parameterize everything. This is not what I'm going to focus on now. All this is described in the lecture notes. Yes? So this is base graphics. This is in R. So another way of plotting this, instead of relying on a column that already exists, log2 intensity, very often in R, we would not want, or in any programming languages, we would not necessarily want to have redundant information. Very often what we would do is on the fly to convert these intensities. So here I have different sets of parentheses, so different calls to functions. I extract the intensity, but this intensity is used as an input to the log2 function that calculates the log2 of numbers. So I could create exactly the same plot, not by extracting the log2 column, but by calculating my logs on the fly. So this is log2. How could I produce this figure with the log in base 10? Log 10. Another useful figure is new function is Boxplot. Okay. IPRG. I'm going to log2 intensity. So this is what I have. This is another way to visualize the distribution of these log2 intensities. But here we will start to hit a little bit of an issue with the way the data is encoded now. This is the distribution for all my intensities, for all my proteins, all my conditions. So I know that from the previous plot and this plot, I see that they have an interesting distribution. That's what I want, kind of bell-shaped distribution. But really, very often what I want to do is to see these distribution for maybe different conditions. So it's possible to do that with Boxplot, where this is a special notation. I won't spend too much time here because I want to move to log intensity. Oh, where is my tilde on this? Yeah. Wrong. So what I ask here is to say, here is my data set. And I want to look at the log2 intensity, but I want to split these intensities based on another column called run. So Here we see how data manipulation becomes essential for the visualization. Here I do this on-the-fly data manipulation subsetting to produce a box plot, a one figure, where now I have these log2 intensities full by different ones. It's possible to change the names. You can't read them here, so it's possible to tilt them and all this, but we're not going to look into this into details. It's all intellectuals. But this is to highlight that some data structures will be really kind of ideal to do some kind of visualizations. And if we want, so like the distribution of all the intensities, this long format is really good. If we want distributions for different runs, we need to do some subsetting on the fly here to produce this figure. And this need to do multiple manipulations on the data before actually plotting them is a good introduction for another package that I have mentioned multiple times, which is ggplot2. As opposed to the base plotting that we have here. Oh, and by the way, base plotting is like a painter's model. Okay? It produces this figure, but without any kind of understanding that this figure is maybe only one step in my data analysis. It plots this, and if I want to add a point, there is the points function. I don't know. Let's see if I say 120. Oh, yes. Okay. Some customization, just that we see. Here's the point that appears. Okay. I wanted to plot a point at coordinates 120. 120. I just happen to know that this is coordinate 1. And I want a red color, and I want a solid dot. Okay. But so this basically, I have this box plot, and I kind of overlay a dot, irrespective of this 1 and 20 mean anything. So it's kind of a painter's model where I add things. There is no way to go back. If I'm not happy with my dot, I have to rerun my previous command and create a new figure, a new plot. Okay. That's the idea of these base graphics. ggplot2 has a completely different mindset. In ggplot2, ggplot2 defines visualization in a kind of rigorous way. We are not going to build up plots elements by elements, where we add dots, for examples. We are going to define our visualization in the following way. So ggplot2 is a function from the ggplot2 package. And the very first thing we need to define in ggplot2 is what are we going to plot? What data are we going to use? And we do this by saying data equals rPRG. And by the way, ggplot2 only works with data frames. It has a consistent interface. It only works with data frames. The plotting functions in base R work with all sorts of data. So we have seen it with a data frame, and so we extracted one column. So it works with vectors. It might work with matrices. They will have slightly different behaviors, but it doesn't have this consistency that ggplot2 has. ggplot only works with data frames. So if your data is a vector, before plotting it, or before visualizing it with ggplot2, you will have to create a data frame. Okay. So the first thing we need to define is what are we going to plot? What kind of data frame? The second, and actually if you run this or that in ggplot2, I think, or in R, you will get an error, because you haven't defined yet how to plot things. The next thing we need to define are the aesthetics. Okay. Out of this data frame, what do we want to plot? Well, we want to plot run and log2 intensities. These are two column names. And I want to bind these to my x and y axis. Okay. And these here refer to column names, but they are not quoted. And that is something special in ggplot2. Although we refer to the column names, we do not quote them, these names. This is something called, it's a kind of special way of evaluating objects in R. So we haven't produced any figure at this stage. We have just said, here's my data set. I want to produce a figure where the run information is matched on my y-axis, and my log2 intensity is matched on my y-axis. And so the last piece of information that I need to provide is how to graphically represent this mapping of my data. This is done with geons. And here I say, I want to visually represent this mapping of that data using a Boxplot. And it will produce this figure. Now, it looks a little bit kind of convoluted, right? From what we had before, Boxplot, what was it, log2 intensity tilde run, and that data was IPRG, and this is a very special syntax. We see where we have the plus here. So the plus here is not like plus the addition operation. It's a reframing of the meaning of plus for ggplot2. This mapping, this aesthetics, plus this geometric or the visualization of the data produces this figure.
So what is that AES?
Aesthetics. So aesthetics, coming back here, defines how do I map parts of my data set to my visual representations, to the coordinates. So in this case, we have x and y. We could have maybe different polar coordinates, things like that. And we'll see that we can have more aesthetics. Let's focus now just on the mapping of columns to axes. Another thing that is very different is that we can save variables in ggplot2. So to save myself some typing, I can say, well, create this variable here, this plot variable, that contains the mapping of this data to these axes. Is a new variable. And now instead of typing ggplot data equals rpag with these aesthetics plus Boxplot, I just say, I should not say just. Sorry about that. It's not just, it's not simple, it's not easy. You know, I apologize. I don't mean to say just, you just do it, because it's not easy, it's not trivial. Sorry, I need to be careful. You reuse this variable, and then you kind of decorate it with the geon. Okay? Sorry, I don't mean to say it's easy, because it's not. It's very special syntax. And so R is going to say, oh, here's a variable. What do I have in this variable? It goes and looks, and it gets kind of the output of this, which is a special type of object. And then it materializes this as a Boxplot. And now it's where ggplot becomes really handy, because we can now start to define these aesthetics with additional parameters. So instead of the questions before in these aesthetics, instead of just defining my x and y axis, I can say, well, I want to fill these Boxplots. How do I want to fill it? I'm not going to say whether this color is, whatever that color is, and I'm not going to say the colors should be red, 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 green, 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 blue, 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 purple, purple, purple. That's the kind of the manual way of doing it, how we would do it in base R. We need to define everything manually. Here we just say the coloring needs to match the conditions. What is condition? It is this one column that we have in the data. So we don't actually plot things in ggplot2. We don't build the plots one by one manually. We define a visualization. We say, I have this data set. I'm interested in looking at the distribution using Boxplots of my log2 intensities. And I want these to be split by a run. And the coloring should reflect the conditions I have. And so now this rather convoluted syntax starts to make sense. There is a reason why there is this syntax. And by the way, ggplot2 is an implementation of a kind of visualization theory called the grammar of graphics. So GG stands for grammar of graphics. That is exactly that. We define the data, we do the mapping of our data using aesthetics, and then we express how we want to visualize it. Yes?
So just in case, I mean, what if you didn't encoded the condition as a factor? So then,
If it was a character, ggplot would automatically convert it, into a factor. Yeah. So it knows that the filling should represent categories.
So you have one field, can you have multiple fields for conditions? Like for you have
A fill here?
Yeah.
No, you would have only one fill. But we'll see later how you can do additional customization. So I'm going to answer your question. I could also files. No. Oh. Okay. And I could also start to do manipulations on this data. Imagine it was not a factor. Imagine it was a number. Okay. I could type factor condition. I can start to do manipulations on this factor or as factor. So whatever this is, first convert it as a factor. Another type of manipulation that we could do is, instead of having log2 intensity, imagine we don't have that column, we could type log2 of intensity. So log2 intensity. You see, it extracted the intensity column and automatically applied the log2 transformation before plotting it. It converted a condition to a factor. And what it does then automatically for us, and in base graphics we would need to do that manually, it automatically creates this legend for us, where we have condition 1, 2, 3 that match the colors. We know it matches. If we have to program it ourselves, we can write bugs. So sometimes the colors on the legend don't match the colors in the plot. And here it automatically tells us what is this legend, what does it refer to as factor condition, because it's exactly what we asked. Here is some customization that we could do. Define the labels, define the axes, to turn the legends around. Okay. Lots of customizations, way more than I can ever remember. Just ignore these customization. Let's just look at this part. This hasn't changed. Now data comes after my aesthetics. That doesn't matter. Whether I first say data and then aesthetics, or aesthetics and then data. I still map my ROM to X, my log2 intensities to Y, my filling by condition. But now, instead of saying geom boxplot, I just change how this visualization should be represented. And there is a geom violin. And now, ggplot uses the same data with the same mapping, but represents it with violin plots instead of box plots. Okay, if you like violin plots. Yes? It cares about NAs just as base plotting cares about NAs. So if we have a missing value in one of these intensities, that value is not going to be plotted. So we don't see it here that there is one value missing. Or if we had a scatter plot and there was a value for X and not for Y, that plot would not be visualized. But where these geoms become very powerful. So here I create this P variable that contains my mapping. So P plus geom box plot creates the box plot as we had before. And that's how a way where we start to build our plots, the way we were creating our subsetting commands, step by step. Instead of having a geom box plot, I can also have a geom jitter. So what jitter means is I take my points, the points for this first run, so they should all exactly align along this road. But jitter creates a little bit of kind of noise on my x-axis. So for my first run, I had this point that had this intensity, this point that had that intensity, 2 points that had very similar intensities. If I didn't have any jittering, all my points would be exactly aligned here. So jittering kind of moves them a little bit to the left, to the right, to avoid these dots to exactly overlay each other. So what have I done here? It's not very useful, but we'll get there. I asked, here's my mapping. I want to visualize them as boxplot and as jitter plots. ggplot to first produce the box plots and then overlay these with the jitter plots. I don't see the box plots. What I really want is have the jitter plot and then the box plot overlaid. How do I do that? Anyone has an idea? I switch these two, which now produces this. First my jitter plots and now my box plots. Why would I want to have both? The box plot gives me kind of general parameters of my distribution, and the jitter plot shows the actual value. Every protein intensity has a dot. It's still not really useful. There are too many dots, all black. So I now add parameterization to my data, and I say I want to have an alpha value for my jitter, for my jittering. Alpha 0 means completely transparent, I don't see anything. 1 means totally opaque, which is the default. Now I want to have this a 0.1. 0.1 actually, if I have 10 points that exactly overlay, they will look like opaque. Otherwise, they will have kind of 10% transparency. Here is, this would be, I don't mean to say it's not impossible with basic graphics, but it would be much more involved. This is relatively easy. But what really matters is not the output, the final output, whether we like it or not, whether it's appealing visually or not. What really matters is that this visualization, we created it stepwise. We created P, which contains the mapping, the data and the mapping. And then we said, oh, what if I visualize it as box plots? Okay, that's interesting, but I still want to see my individual dots, so I added a geom jitter. Then I realized, no, that's not good. I need to swap them. And then I said, oh yes, all right, that's not too bad. But my dots are actually too opaque. I don't see anything left. So let's do an alpha. So this kind of stepwise reasoning on the data is the same one whether we do data exploration, subsetting, or plotting. And the last one before I give you time to try this out is faceting. Faceting is something extremely powerful. This is the same code as we had before. Not exactly. Here I do the mapping of technical replicates. I still put my log2 intensities and the fading is on conditions. But I still want to visually express this as box plots. But another feature of the data is that I want to have facets. Okay? So I don't want to split here based on colors with filling, but I want to have subgraphs for my data. These are facets. And the faceting should be done based on conditions. Okay, so facet grid will take all my data and first split it based on conditions. Create a facet for the different conditions. And do the same transformations and subsetting as we had before, or the same mapping including the filling. And this can really produce very elegant and complex visualizations with faceting and grouping and filling that would be very difficult to produce. But what I find important here is not that we produce a figure that we think is beautiful or not. What really matters is this flexibility, so this syntax that we need to learn, which is not trivial, whether it's for ggplot2 or the data subsetting. But these flexibility, these new tools that we learn that allow us to produce figures that are not just nice, elegant, but that can highlight interesting patterns in the data that we would not be able to look at without all these transformations.
So how is different faceting?
Oh, sorry. Plots, so I can decorate with additional information. And so the function to create my faceting is called facet_grid. And here the factor, the piece of information that needs to be used to do the faceting is condition. And here we recognize our condition 1, condition 2, condition 4. And the tilde here means that do the faceting based on the condition. I could have something before my tilde here. Imagine I had run. No, these are already runs. But I could have another variable before my tilde. And then I would have a two-way faceting. Conditions along the columns. The right-hand side, for the data frames, we had a comma. After the comma, it's column before the comma, the rows. So if we had, let's call it variable A before the tilde, I would have my condition, my faceting here along conditions like this, and my faceting along variable A here. So, I would have a grid of subfigures that is produced through the faceting. Here I only have one condition, one factor for the faceting, but I could have two. I could have something tilde condition, and the something would then split the data along rows. Yes?
But I see so on the X, so the X is now type replicate, not run, because if you do run, then it'll have gaps wherever there's not.
Yes, you're absolutely right. And so here, my X is technical replicates, A, B, C, A, B, C, A, B, C, A, B, C, yes. So my suggested exercise here is go through this ggplot2 syntax, which is very special. I thought it was very confusing the first time I discovered it. And reproduce these figures that are here. And then try to modify them. For example, where you could create a geom Boxplot on top of a geom jitter, like we had before, but don't produce log 2 intensities, but log 10 intensities. We don't have the log 10 intensities in our data frame, but we can use the log 10 function like we did before for the base, was it hist. And then please do explore the customization a little bit more as described here, where, for example, we changed the title, the X and Y and X label, and where here we tilt the name of our columns. And the last thing I want to say is that ggplot2 is very complex, but has a very good documentation page online. So if you Google for ggplot2, the kind of main web page is called ggplot2.org, and there is a link here to documentation. That, for example, here describes all the possible type of layers, the geoms that you can have, type of statistical transformations, and we'll see some tomorrow. What kind of aesthetics. So there is a lot. There is way too much to learn, or way too much to remember. Additional information, if you want to explore different customization, here's the changing scales, faceting here, Where was I? So try familiarize yourself. Try these different plots by yourself, and once you have familiarized yourself, change this one thing, which is plotting the log 10 intensities. Okay. So when you have finished, or you have tried enough, green sticky note. Otherwise, please call us if you have specific questions, or just ask them, and maybe everybody could benefit from them. No. So maybe if we could explore this ggplot syntax for 10 minutes or so. So for the last 5 minutes, we stop at 12:30. Let me check. Yes, can anyone confirm this? 12:30, yes. And so for the last 5 minutes, I'll show you how to save these images in PDF files or PNG files, and how to save the output of some of the things that we created on this, so that we can switch the computer off and easily record for the last 5 minutes, and 10 minutes ggplot2 and so on.
So you have to add facet grids to both the plot steps separately for jitter and back. What happens is the jitter kind of covered on the balance.
Yes.
So you have to prove the kind of facet grid usually for your value and or if I switch it, it's gonna be
So here what do we have? Let's because here you say fill is now it creates some body for your conditions because you ask these to be called together. But the fundamental um, splitting of the data of your data is still by technical C. So if now you add jittering, it adds everything for A, everything for B, and everything for C. So the colors that you see here are actually not the main separation of data. It's just a side effect of asking for the coloring. So in this case, probably what you maybe guess for the wall and maybe so now your fundamental is the separation of your first level, right? And then this, your different technical should be explored on different methods. And to some extent, you don't really need coloring here. So the faceting example that I showed was coloring and faceting display the same type of colors. So depending on what kind of operations you ask, it will do exactly what you want. But here, because your fundamental splitting of the data was based on technical reference, the jittering did the jittering for technical reference.
Right, but the jitter is more representation of the data point, whereas Boxplot works and throws out the kind of the saves the kind of
So the
overrides those.
the statistical properties, the distribution. So it will tell you what the median is, what the box tells you this is where you have 50% of your data, and then the kind of whiskers is the inter-quantum regression, and then you might have different quantum sizes. So value plots and the box plots gives you general parameters of the distribution. The jitter tells you which individual points. So if you have different type of information, sometimes you want to know individual points, sometimes just the distribution. So what you had before is confusing, and it's not what you wanted, but it's kind of a reflection of how you do the case. that's geom points. So scatter plot would be, how do I want to represent this? So if you, I don't know, here you could say the intensity and log2 intensity. X is 1, X is intensity, Y would be log2 intensity. And there, because X is mapped to a continuous variable and Y is mapped to a continuous variable, one way to represent this would be a scatter plot, and that geom is the geom plot. Okay, we have 4 minutes left, and I would like to conclude this morning's session by showing you how to actually save the work. All the work that we have done so far is stored as variables inside R. But at some point, we will want to save these to disk. Or in particular, the figures that we have, we would want to save them as a PDF file, as a PNG file. So by the default in RStudio is to represent the figures in this panel. And with RStudio, we can export the figures here, save as image or save as PDF. And that would then create a file called rplot.pdf. And if I save it and I look at my files, it created this rplots.pdf instead of the visualization in R. But if we have a script that automatically generates figures, a little bit like the read.csv, where we can click on import data, it's also useful to know how to create these PDF files programmatically. And this can be done with a function called PDF. Okay. So let's assume I want to create a PDF file that contains a figure, and I want this file to be called myfig.pdf. I'm going to remove any figures that I have here. So if I say PDF, myfig.pdf, and by the way, this could be PNG, myfig.png. I choose to save it as a PDF file, but I have the same principle for PNG, JPEG, and so on. So if I call PDF, nothing happens here in R. If I type P contains this ggplot object. P is not displayed here. P is going to be displayed in this PDF file, or this PDF device that I created here. And now, to finalize this plotting into this PDF file, I would type def.off, enter. This created this new PDF file called myfig.pdf that contains this figure, which is equivalent to first. Now, I closed my PDF device here, which is really equivalent to displaying the figure in R and then manually exporting it to PDF. But within a script, I need to be able to do that automatically. Yes?
So when you first type P, what does it mean?
Oh, P is the variable that contains the ggplot visualization. It's also kind of a nice trick. I store all my visualization in P. So I'm going to clear this. If first I create kind of technical term here is I open a PDF device. Now I don't want to print on my screen device. I want to print or visualize in a PDF device. A PDF device is a PDF file. So PDF opens a PDF device. And from now on, all the plotting that I do is not going to be displayed in my screen device. It's going to be displayed in my PDF device, which is another word for saying write my figure to the PDF file. Okay. So it looks like nothing happens, but actually something happens on this file. And now I have to close my device. Def.off. Close my device. And this, I repeated exactly the same operations, creating a myfig.2. So this is summarized. Here, device, my plotting, closing my device is how I could automate the generation of figures. And I could create hundreds of figures, thousands of figures like this, which is not necessarily useful, but that is how I would do it. I would write a script file, and a PDF, DevOps, and then production of many figures.
To have the same file name, does it prompt to change the name or anything? Or?
So the default name is rplots.pdf, which is why here I provided a file name manually. So if you plot to the same device in a PDF file, you would have a PDF file with multiple pages. If you wanted to create these figures in different files, you would need to programmatically create the file names.
And why do you have to save off?
To close this device. If you don't say, oh, let's try. I create figure 3, P. Okay, you see figure 3, sorry, here has appeared. If it's not closed and I try to open it, it complains. I can't open it because the device for it to be finished, finalized, needs to be closed. This is not a valid PDF file because it hasn't been closed properly. So this does not work. Oh, wrong button. Here. I first need to close my device. And now the file has been closed properly. The file information in my PDF file has been written to the file, and now I can open it. This is how I could save data. Quickly, two ways to save, this is how I write figures to disk. How to produce data, how to save data to file. So we created this rprg, 1 for condition 1. So there would be two ways to store it to a file. The first one, which would be the slightly preferred way, is to write this data frame as a data frame to a disk in a special format specific to R. And we can do this with the save function. So what do I want to save? IPRG1 data frame, and I want to save it in a file called IPRG1. It doesn't need to have the same name. .rda. RDA is the kind of standard extension for R data. Or another extension that people use very often is R data like that. Maybe RDA is shorter, less typing. Okay. Save. And this creates here IPRJ1.RDA. So this is not a file that I can open with Excel, it's a binary file. But it's a file that I can send anyone that has R, whether it's on Windows, on Linux, on Mac, it doesn't matter. That file, it's an efficient way to store R objects on disk and guarantee that these R objects can be opened by any other version of R on any other platform. So if I save, I need also a function to load it. So what I'm going to do here is that I'm going to remove, just to show you how it works, I remove IPRG1. So I delete, you see, it's not there anymore. But that's not a problem because I stored it to a file. How can I load it back? It's with load IPRG1. So I load a data from a file, and that's what needs to be quoted, because it's the name of the file. Enter. And now IPRG1, I'm not going to type its name, otherwise it's going to print many things on screen. But now IPRG1 is again available, and it's a data frame. Save to write it to disk and load it. But sometimes an RDA is not what you want. From an R point of view, that's exactly what you want. But if you want to submit supplementary information, you would not send an RDA. You would send a CSV file, for example. And for that, just as we had read CSV, we have write CSV. Same principle. Instead of reading, I write a comma-separated file. I need to provide the data frame that I want to save. And write CSV really does only make sense for data frames or matrices, not for anything else. Save will work with any type of object that we have. And I want to write this to this file. I'm missing a G. Enter. And it appeared here. And this is a CSV file that is kind of representation in CSV format of the data frame that we have. And we could then read CSV this file again. Okay. Apologies, we're a couple of minutes over time. Thank you very much for following throughout the morning. I appreciate it is a lot. It is a lot. And although there was no magic trick, I really tried to be honest to tell you all the new commands that you need to know to do the subsetting and things like that. But although individual commands are not too difficult, combining different commands, the complexity increases. But with a little bit of practice, I'm sure that you'll become very familiar with the subsetting. And same thing with ggplot2, very awkward syntax. But I guarantee you that by tomorrow, if the last hour, if we practice together, we can do all the exercises together if you want, or you can do them on your own. Just let me know throughout the day what you want, and I guarantee you that you will very quickly familiarize yourself, and it won't feel weird anymore after a little bit of practice. If it still feels weird, and maybe it does, it's perfectly normal. Just let me know, and we can go over the material again. Right? This afternoon, basic statistics with Mina, and the lecture. The first lecture on basic statistics with Mina. Okay. Thank you very much, and see you in a bit.